Good morning or good afternoon or evening, everyone. Thank you so much for joining our Sysdig webcast today. We'll be talking about the 5 must-dos when implementing cloud-native security in Red Hat OpenShift. I'm Jennifer Pospashek. I run Sysdig's event, field, and partner marketing programs. I'll be your moderator today. And as you know, Sysdig is pleased to be a Red Hat certified technology partner. We've completed several integrations with their technology offerings, including OpenShift, and we're looking forward to talking with you more about that today. With me is Jorge Salomero-Sanz. He is our Director of Product and Technical Marketing. He's responsible for our integrations, enablement, product introductions. He's also been a featured speaker and contributor on open source and modern application development topics like microservices, security, monitoring. So I'm really pleased to have him join us today. And before we just jump into our topic, I do want to let you know that we very much welcome an interactive session. If you have a question along the way, please go ahead and send it to us using the Ask a Question tab under the video screen at any time during the presentation. And so with that, I will hand it over to Jorge.
Thanks, Jennifer, for hosting me today. Today's topic is about security, about Red Hat and OpenShift, and we will be covering all the security features that are part of the Red Hat OpenShift platform and how Sysdig can extend those from the platform into the container lifecycle. But let me start with why we are here. One of the fundamental problems that enterprises have when moving to containerized workflows and container platforms like OpenShift is that secondary operations, they challenge them with problems or topics like monitoring, security, observability, and basically this change of paradigm, this change of the infrastructure platform creates these challenges, which is mainly around visibility. You cannot defend talking about security what you cannot. We have seen how in the past couple of years, as more organizations were moving to containers, some security incidents, they were going public. So this is a reality. This is something that challenges organizations on containers, and today we are going to talk about it. OpenShift platform provides a number of great security features that actually have provided great confidence to enterprises and users to start moving their applications into containers, microservices, and OpenShift. And actually, we can also group all these features around 4 groups or areas. Traditionally, Red Hat Enterprise Linux and now Red Hat Container OS based on CoreOS operating systems, they provide a great level of host security. That's the baseline where we are going to build all the infrastructure and all the systems. Additional components like SE-Linux, SecOps, or container capabilities increase the security confidence, the security restrictions of each of the services or containers that we are running. As we bring services and users into the platform, we need to basically authenticate and authorize each of these consumers, either if it's a service or a user. For that, OpenShift provides airbag capabilities, so we know who is who, either if it's a service or a person, and we have advanced authentication mechanisms like OAuth that can be connected to your external systems, services they get service tokens. So basically, any peer in the platform can authenticate and authorize against what the action is going to perform. As part of the entire OpenShift platform, we see a number of orchestration-level security features that they come from the Kubernetes world, like admission controllers, pod security context, pod security policies, network policies, resource management, like how much resources in terms of CPU memory can a container consume, or secret management. All these things, all these features, they are now part of the platform, so we can start using them right away. OpenShift and Red Hat products, they always come with OpenSCAP. OpenSCAP, it's a framework, it's tools that help you audit your regulatory compliance status of your infrastructure. So that's a great set of tools to check if your configuration is secure, your applications are secure. And then finally, as we're talking about containers, OpenShift and Red Hat has an open source project for image scanning, Claire, and also a service, a hosted registry service, Quay.io, that integrates service. So as a baseline, as a platform, we have a great number of security features that help you move containers with confidence here. So you know that what you're using is highly secure. The problem that we see with the people we have talked to, with people that they get challenged with these day-to-day operations, is that now these applications, they have challenges that are not part of the platform, that how we manage this into a growing organization with multiple DevOps teams, how we handle policies at scale and in dynamic fashion that adapt to OpenShift, how I protect from the different attack vectors into my applications, or how I can establish different perimeters for isolating when there is a security incident. So we are going to see how we can do a bunch of things to protect from these scenarios. The problem is that legacy tools, they then basically work with this new infrastructure. They have no visibility into containers. They struggle when things come and go, like we see in Kubernetes and OpenShift. They don't understand the context, the orchestration context, like namespaces, deployment services. They are not prepared for DevOps. Some security tools that they claim to be cloud native, they exist, but they are really niche. They use one thing, or just focus on the image scanning. They don't have deep visibility in what's happening inside the containers, or they don't understand all the context that OpenShift provides and how the applications they are deployed or orchestrated. So we are going to see how visibility it's useful for both monitoring and security, and we are going to see how different workflows they are going to useful to bring that security into the application level, into the DevOps continuous process and workflows in the organization. Basically, what we are proposing is, what if we could pull in from different, very comprehensive data sources like process activity, file activity, network activity, orchestration activity of the OpenShift API server, system metrics, platform events, service metrics, custom metrics, and we could combine all that information that gives us great insights and what's happening in our infrastructure, inside our containers, in the applications, with all the context of clusters deployed across different cloud providers, OpenShift metadata, so I understand my projects, my deployment configs, my pods, and all the information from my services, including like labels, any metadata, and service definition really. So with all those insights, we can build workflows around vulnerability management, compliance and audit, runtime defense, digital or container forensics of incident response, and how monitoring and troubleshooting is also important for security. Basically, what we are trying to do here is, rather than having all these security features to be one endpoint implementation in the platform level, to up-level all these workflows, implement security across the entire container lifecycle, and make this a continuous process, not a one-time step. So if I'm at build time, my developers are building the containers, I can do image scanning, I can check for compliance at build time, microservice topology, so I understand the different components in my application. When I deploy the applications in my OpenShift clusters, I can look at the performance monitoring, at how the applications behave on production, and if there is any runtime issue, and audit all the behavior in general. In the incident of a policy violation or a security incident, how I can respond, how can I do forensics and post-mortem analysis, how can I troubleshoot any issue. So we are going to see how this is an ongoing process and how we can incorporate security as part of this pipeline. And we are going to talk about 5 must-dos, 5 areas that I don't want to see these as 5 things or 5 steps, but rather 5 phases that we are going to be implementing as an ongoing process. So we saw how all these, or most of these concepts, they were part of the platform. Now we are going to see how we can up-level these into the container lifecycle, how we can do image scanning, CI/CD integration, vulnerability reporting in terms of vulnerability management, how we can do compliance and audit, and actually start implementing different regulatory standards like CIS benchmark, NIST 800-190, PCI, EPA, GDPR, etc. How observability is a fundamental part of the security process, not only of the operations process. How we can defend against any incident in our applications, and how we can leverage the deep visibility that we were talking before, how we can leverage techniques like machine learning to implement our policies, and what are the challenges of doing digital forensics and incident report on containers, how we can block those threats, how we can do that post-mortem analysis even if the containers, they are long gone, so I cannot investigate. And actually, one of the things I like to say is that here we see like 5 phases, but it's very important to understand that compliance is a phase that extends across vulnerability management, across runtime, across incident management. Some people, they see compliance as a one-time stop, but we will see how compliance needs to be implemented at build time, at image scanning time, but also how we implement compliance at runtime or when there is an incident. So let's go through these different 5 steps, and I'm going to be sharing my screen and show you how these processes, they can be implemented in an OpenShift platform. So our first phase, our first must-do I'm recommending today is establish a process for vulnerability management across your cloud-native applications. So we mentioned before how OpenShift can analyze the packages available in your images and detect any vulnerabilities. Actually, Red Hat provides a container catalog where they update all the containers and they give you assurance that any container being downloaded from that registry, it's very secure. But when we are building in-house our own applications, or we need to pull containers from other registries, we can go a little bit deeper, and we can analyze not only operating system packages, but also third-party libraries that I'm pulling, or the developers that are pulling the containers. I can check for best security or security best practices, like, for example, on how I can build my Docker file. For licenses, I can integrate these image scanning process as part of my CI/CD pipeline, either if you're using Jenkins or any other CI/CD server software. Also scan images from different registries. How I can leverage OpenShift specific mechanisms to define which images can be deployed or not into your cluster, like a mission controller or OpenShift image policies. How I can directly whitelist or blacklist specific known vulnerabilities that might not be affecting my applications by the CVE or the images. How can I query all these huge inventory database with all the vulnerabilities and understand what was my status at a point in time? How can I bring runtime awareness into the vulnerability management workflow? And how can DevOps teams implement alerting for image scanning? So I'm going to share my screen for a second, and I'm going to show you a little bit how this can be implemented. So I have here my OpenShift container platform, and as you can see, I have deployed a number of applications. This is what I'm going to be using today. We mentioned before that Red Hat tools like Quay.io or Claire, which is the open source project underneath, provides a very comprehensive package vulnerability scanning, so I can see that in this or in any specific image there are known vulnerabilities. But the challenge often is how I up-level these features, how I can make them as part of my application level. So I'm going to show you how this is implemented on Sysdig, secure, but I want also to focus on the workflows, like how I can do this an ongoing process in my pipeline. So what I can see here is multiple policies, and this is already a very interesting point. I need to establish different policies, different scanning policies for my different environments. A scanning policy basically will be checking for known vulnerabilities or for the best practices I was mentioning before, if someone is executing a container as well. Another very interesting thing is you can compare what's just runtime status. So imagine I'm a developer responsible for this very specific application. So I can just go into the scope of this application and see, well, I have a number of images that haven't been scanned and some other images that have been scanned. Some of them they pass, they don't have any vulnerability, and some of them they have specific vulnerabilities and access into the report and understand how the image was evaluated, did these pass, these checks pass, these other pass fail, and what were the vulnerabilities found. Another very interesting process to establish is being able to query all that information. And one of the nice things here is that you can basically join the dots between runtime awareness and all the information that you are collecting while you scan your images. So, for example, by being able to say, just show me the vulnerabilities of the containers that are being executed right now, and actually give you a little bit of context, like in which host, in which cluster, in which namespace, or in which specific deployment I can find every image and what's the vulnerability. Being able to build complex queries to understand what's your security posture here, it's really, really important. Last but not least, if you are using CI/CD tools like Jenkins, being able to understand like why a build failed, and if it was because of a security issue, being able to see the policy, how the policy was evaluated directly from Jenkins, and understand why it failed, like the vulnerability, secrets leaking to the container image. This is really useful and helps you shift left your security. Let me go back to the slides for a second. And let me talk about compliance and audit. And this is something I was mentioning before, that some people understand compliance as one check. You need to run a number of checks or scripts, and I will be passing or I will be failing, but that's it. Now, compliance, we need to understand that something as an ongoing process that's implemented at different layers or different processes, like image scanning, like runtime, like incident response. There is a good number of different regulatory compliance standards that we can use to follow best practices or regulations in our containerized infrastructure. And the interesting thing here is that they have recommendations that can be implemented in different ways. And actually being able to also audit anything happening at the host level, at the container level, or at the orchestration level, it's also going to be useful to implement these processes. Let me share my screen again, and I'll show you a couple of workflows for this. So back here, as I'm implementing my image scanning processes, for example, regulatory compliance standards like NIST 800-190, they have specific recommendations like we cannot run containers without the user directory, so therefore run as root. We can also check it out as an affected user. We do not recommend using the add instruction, but the copy instruction instead when writing those Docker files. We need to check for possible credentials being leaked into the image. And like in general, we should then push into production any container that has known software vulnerabilities, either if they are coming from operating system packages, RPMs, devs, whatever it is, or third-party libraries that the developers are pulling inside the image. Like it could be JavaScript packages from NPM, Ruby from Ruby gems, Java jars, etc., etc. Another point in time where compliance can be implemented is in runtime. And here we can see how, actually let me show it from the library, how different standards can be implemented. So for example, the Mitre attack framework has specific recommendations for different things that we should check. So for example, this execution, we can check about someone executing an interactive shell inside a container, or someone deploying or spamming an unexpected process inside a database container, or even troubleshooting tools like Netcat. So we can write specific rules for these kind of like regulatory compliance. Of course, CIS benchmarks can be executed, and you can check these. They have specific recommendations, like make sure you configure Kubernetes OpenShift this way or this other way, or you can also check for, let me see if I can find it here, like Docker benchmarks, and see, for example, I am deploying a Parmer profile, I'm exposing the host inside a container via volumes, or for example, when I'm building images, I check for root, I check for health check. So these, all these checks, they can be implemented in different ways. So I'm going to back to my presentation. And the third stop, or the third must-do I want to talk today, is about observability. And this is actually something quite new. We think that observability is part of the security process. In containerized workflows, the specific attacks like denial of service or crypto mining, unexpected processes, rogue connections, new deployments, misconfigurations, over bugs are things that you would typically track in a monitoring tool. But you can, these events or these scenarios, they also have an impact to your security posture. Additionally, people understand security events or policy violations as a one-point event. But sometimes we want to also see security as an ongoing process. So these point-in-time events, rather than being part of a report, we can see them as metrics. Metrics change or evolve over time. So if we want to understand what my compliance posture right now and what was 3 weeks ago, I can, if I'm looking at it through a metrics perspective, I can see how that changes. Let me share again the screen and give you a few examples. So one of the things that I really like is as I deploy a new microservices application, being able to understand like how are the different components and the dependencies between the different microservices is fundamental. So being for that, you need to have insights in all of the connections, but at the same time, you need to understand how the specific microservice application is being deployed in OpenShift. So whether it's a project, what are the different deployment configs, where I have inside each deployment, like how many pods, and if there is a load balancer, how the traffic is being distributed across it, et cetera, et cetera. Another interesting perspective is being able to understand how those compliance, compliance over time. So if I want to look at all the containers that they are running as privilege, I might want to be able to see that as a metric per host. Or if I want to see like containers that they don't have a second profile, or containers that they have access into the Docker or the Containerd or the CRYO socket. So these are different checks that they can be changing over time. So being able to detect these, it's very interesting. The other, let me see if I can see it here now. So another very interesting approach is being able to understand, let's see if I can pull this here. Oh, sorry, I'm in the wrong section. So being able to look at all the policies that they were, all the compliance metrics. So imagine I'm interested at looking at all the containers. So in this case, this is like section 5. Let me look for unspecific. So imagine I want to look at this runtime test pass, and I want to see these by host. So I can get that metric and see like, oh, these hosts, they have this compliance level, and these other hosts, they have less compliance level. So I can very quickly isolate or identify where I need to improve and how that can change over time. So in this case, I can see like how there was like a change in that host, and for a specific time, my compliance posture changed. Now let me move into my next section. All right. The fourth stop is runtime defense, and this is very interesting. Runtime, it's actually the longest period of the entire container lifecycle. And this is something that sometimes it's ignored, it's missed. And it's very important because before we could see how different deployments or how we were scanning the different images and how we could find vulnerabilities inside of those images. But what about things that they are not known to us, like zero-day vulnerabilities, configuration issues, vulnerabilities specific of our software that they don't have a public CVE, etc., etc. So being able to have a very deep and full understanding of everything that's happening inside the containers in terms of processes, network, but also file system activity, like which files I'm reading, which files I'm writing, or every single system call that's been executed on the system. Having access to all of the information and being able to bring together with orchestration awareness and platform features like secret management, fault security policy, or network policies allows me to have a better control of everything that's happening at runtime. Additionally, one of the very interesting things that we have done here at Sysdig is this Falco project. Falco is an open source and now community-driven project for runtime behavior monitoring. So you can define how you expect that a container should be behaving, and if it's not for that defined pattern, that defined policy, you can understand that as a security incident. It's very important that Falco, unlike any other tool, runtime security tool, like could be SE Linux or a Parmor or SecOps, it is full microservices and OpenShift aware. So you can define these policies based on that metadata, how you deploy your applications. Things that we can improve and provide a better enterprise workflows or better experience on top of Falco is like being able to bring techniques like machine learning to build up policy. And the benefit of this approach is that rather than looking into a checkbook-like feature, now we have full understanding using or leveraging the Falco engine to understand how the different policies are implemented, and we have control on how we want things to be evaluated. Additionally, Falco is a very growing and fast-moving community, and we see contributions from different companies and organizations of new rules, of new use cases. So you can actually leverage those to implement your runtime security policy. Let me show you a little bit how that can be implemented. Let's see the screen. There we go. So, as I was mentioning before, Falco provides a default rule set, or Sysdig has a default rule set based on Falco rules, and we have different categories that we can bring together. So, imagine you wanted to look at Kubernetes or OpenShift rules. And the interesting thing here is that, for example, if I want to audit things that the users are doing against the OpenShift or the Kubernetes API, I can actually write rules for that. So to give you an example, and this is when I was mentioning having been able to have control, how the things that were under the hood, access about how those rules are implemented. So I'm hooking into the Q Audit API, and I'm being able to capture or to audit when someone is doing an action and it's against a poll resource, and the command either is in an exec or an attach. And I get information about which user executed that action, in which pod, in which namespace, etc., etc. If I want to look, for example, into how someone can execute a shell into a container, I'm able to access into this rule definition. Building your policy from this is very easy. So you can get any policy, have access to the rules, and then being able to apply any of the metadata available. So imagine I wanted to apply this into a specific namespace, I would be able to do that. Last but not least, in order to respond to any of these events, I can stop the container, I can pause a container, I can implement different actions. And actually, let me show you how that could be done. So back into my slides. This is already the container forensics and incident response. Through these policies, that I can either build manually myself, I can pull them from the file code library, or I can leverage machine learning to create that profile, to create that safe default behavior of my container. I'll be detecting possible security violations, security incidents. But how can I respond to these incidents? Well, the most important thing is if you're working on a containerized platform, in a containerized infrastructure, things they move fast very quickly. These infrastructures are highly dynamic. So being able to automate that response is fundamental. And being able to do that from an OpenShift awareness perspective, it's very important. So if I'm able to stop the container, pause the container, quarantine, pin the node, like being able to do all these actions at the orchestration level, it's fundamental. It's also being able to follow anything executed on the system or anything executed against the API is going to allow me to understand the context, what is going on. And last but not least, one of the biggest challenges doing forensics in containers is that if your orchestrator reschedules the pod, scales down the service, or any of those events that they are not under your control anymore, that can destroy the container. And because when the container is gone, you only have any possible logs that you can do, but nothing else. You cannot SSH, you cannot cube exec into that pod and do or perform further forensics. Basically, you're gone. One of the very interesting approaches here is being able to take a capture. A capture allows you to dump into a file that it's stored outside your platform all the activity that happened during that security incident. And that's going to give you everything you need to perform forensics. So sharing back my screen, let me show you how that could be done. So imagine I'm looking at all the security incidents of my OpenShift cluster, and I see that in this specific application, like someone ran a shell into a container. Being able to understand what happened, in which Kubernetes application, in which host, in which container, how someone, this user root, the Docker exec, and this is a lot of information to understand what's happened. But being able to audit all the commands executed and being able to associate them into this security event allows you to respond very fast. Here, the container was stopped, so we couldn't, this attacker couldn't continue with the attack, but we can see all the steps that they already executed. So download, open a shell, downloaded some kind of files, possibly a malware into my system, uncompress it and install it into my system, and then shred the bad history to delete the steps behind him. So this is very suspicious activity. I can see a lot, but thanks to this capture functionality, I'm now able to have access to all the system activities. This Sysdig Inspect tool is something also open source. So this allows you to do very deep forensics into everything that happened without having to go very deep into the system. So I can pull in through these tiles into a timeline in here, my notification, alert, some of my file activity. I can also bring in my network, and somehow I can see like that there is like an anomaly pattern around this specific time frame. I can filter it, and then I can look at the executed command and look, for example, on how that command modified, see the files that they were read or written, and even reconstruct any of the files and see, oh yeah, this is some kind of like the source code of some malware that this user was going to install on my system. Just a very quick example of what this would be like. Now going back to the slides. Bear with me 1 second. We have the system loading. So that's everything I have prepared for today. We have some extra minutes now. And Jennifer, if you're still there, I was wondering if we have any questions from the audience today.
Yes, we do.
Awesome.
Yeah, we have a few here, and I just sent out a note to the audience suggesting if you have additional questions, please go ahead and submit them now. So one of the questions that we have coming in is, you were mentioning RBAC before. OpenShift has an advanced permission system. So can these permissions be applied to all the new security processes?
That's a very interesting question, yeah. OpenShift has this RBAC system that allows to define which or what a user can do against the system, or what even a service can do against the system. But that's at the platform level. When implementing these security processes with a tool like Sysdig Secure, being able to define, yeah, like so these users, they have access to the vulnerabilities of the applications in this cluster, or the developers, they get access or they get notifications only to the vulnerabilities that they are, the images that they are using in their applications. So that very same philosophy can be implemented in the security processes, leveraging OpenShift users and OpenShift metadata. So we are going to do that to set up alerts, to set up permissions, etc., etc. So basically, you can say that it is possible, actually, with tools like Sysdig Secure, to join those dots between the permissions of the platform and the permissions at the security process level.
Okay, great. So then the next question that came in was around Falco and Sysdig Secure and the security capabilities. The question is just around, is Sysdig open source? What's the difference between Sysdig and Falco? So a little more color on that for our audience would be great.
Yeah, perfect. So Falco is the open source community-driven project. It was started at Sysdig, but now it's whole under the CNCF umbrella, and it's not only us, but a growing community who develops the upstream project, who contributes rules, who contributes documentation, who contributes integrations with other security tools and other systems. Falco purpose is basically detect any anomalous behavior happening in your containers, okay? And that's one and a specific single purpose of Falco. Can also detect system activity and Kubernetes or OpenShift API activity. Now, that's just one specific use case, one specific phase of this ongoing process. Sysdig Secure integrates the Falco engine as part of the commercial offering that and then provides like an enterprise experience on top of Falco. So you have a UI, to build, to customize, to maintain all these rules and to build your policy. You can leverage machine learning to create these profiles of these rules for your containers automatically. You can create different permissions, as I was saying just in the question before, to define who has access to who and who can change everything. And then outside of the runtime security, Sysdig Secure also does compliance, vulnerability management, response, incident response, and forensics. So that could be the difference.
And then the last question that we got and just came in is around installing and testing the platform. So they just are curious, what does it take to install Sysdig? How can I test the Sysdig platform? People want to get their hands on it. So.
Okay, yeah. So if you want to install Falco, the open source project, we have an operator on operatorhub.io, so you can install it directly from there. For Sysdig Secure, the commercial, the commercial product, the agent can also be deployed using an operator and using the certified container from their Red Hat container catalog. And then the backend, where everything is configured, it can be consumed SaaS from us in the cloud, or you can all deploy it on-prem if you want.
Perfect. Thank you very much. That exhausts our questions at the moment. So what we'll do is we'll just close, and on behalf of the team at Sysdig, we want to say a big thank you to our audience today for joining the event. Check out the attachments tab. We've got some great resources and links in there for you to learn more about Sysdig and Red Hat. And as well, we have some really good webinars that we're planning and getting ready to unveil for the fall. So we just ask you to stay tuned to our Bright Talk channel as those get posted. Thank you, Jorge, for your time and for a great presentation today. And again, thanks to our audience for joining us. Have a great rest of your day or evening. Take care. Bye-bye.
Thanks, everyone. Bye.